Hello, I welcome you all in this session of hydraulic machines. In the previous session, we have seen the maximum speed of a reciprocating pump during suction and delivery stroke. In this session, we are going to see the air vessels of a reciprocating pump. We know that in the single acting reciprocating pump, discharge is intermittent or pulsating. So to get continuous discharge from the single acting reciprocating pump, the device called air vessel should be attached at the suction and delivery pipe. So the device here shown in the figure is called as air vessel. Air vessel consists of air at the top and water at the bottom. From the bottom, water may enter or may leave to the delivery or suction pipe. So these devices are connected very close to the cylinder. Now let's see how air vessels are useful to deliver the continuous discharge. So let's see first what is going to happen in the delivery stroke. So at the beginning of delivery stroke, the piston is at ODC, outer dead center. At the first half, the piston get accelerate, and in the next half it get retard. Same thing is going to happen. The liquid which is in contact with this piston get accelerate in the first half and then get retard. Now let's say about what is going to happen in the first half of the piston. So in the first half of the stroke, due to acceleration of the piston, velocity of water is more than the mean velocity. Mean velocity is the velocity of water which is required to be delivered from the delivery pipe. In the first half, velocity of water is more than the mean velocity due to acceleration of the piston. So discharge of water should also be more than the mean discharge. So from here, discharge is more than the mean discharge. Due to this more discharge, pressure at the entrance of air vessel is more. Initially, pressure inside the air vessel is less. So water is now easily move inside the air vessel. So excess amount of water can be delivered to the air vessel, and water from the delivery pipe should be getting the mean discharge. So in the first half of the piston stroke, excess amount of water will be supplied to the air vessel. Let's see what is going to happen in the next half. In the second half, piston get retard, so water get retard. Its velocity should be less than the mean velocity. Therefore, discharge of water in the delivery pipe up to here should be less. As discharge decreases, pressure at entrance of air vessel should also decreases. So air which is compressed earlier in the first half now going to impose the force on the water, and that's why water with high pressure will delivered from the air vessel. So discharge from the air vessel is now supplied to the delivery pipe. So in the second half, additional amount of discharge can be taken from the air vessel such that the discharge from the delivery pipe should be uniform and with the constant rate. There are chances of deviating the discharge in the small distance between the cylinder and air vessel. That's why it is always important to fit this air vessel which is very close to the cylinder. Now let's see how we are going to get benefit in the suction stroke by the air vessel. During suction stroke, at the beginning, piston is towards inner dead center. In the first half, piston get accelerate. In the second half, it get retard. Means initially in the first half, water get accelerates. So in the first half, velocity of water in the suction pipe is more than the mean velocity. So due to this acceleration of piston, the pressure drop takes place at the entrance of air vessel. Initially in the air vessel, pressure is more, so liquid will get delivered from the air vessel inside the cylinder. That's why, due to the more pressure difference between cylinder and in the sump, there is no extra amount of discharge will be supplied. So this is about the first half. In the first half of the suction stroke, the discharge can be supplied from air vessel into the cylinder and maintaining the mean discharge in the suction pipe. In the second half, when piston get retired, the pressure here is more than the previous half. So due to the more pressure of liquid at the entrance of air vessel, now liquid get stored inside the air vessel and discharge in the suction pipe can be maintained. So where here it is written velocity of water in the suction pipe is less than the mean velocity. That's why discharge which is entering inside the cylinder is less than the mean discharge. So additional discharge is now going to accumulate inside the air vessel. So in the second half, excess water will be stored to the air vessel. So here it may get confused that in the first half water is going to be delivered from air vessel to the cylinder, and in the second half water is going to be stored inside the air vessel. Now let's see the advantage of air vessels. An air vessel is fitted to the suction pipe and delivery pipe at a point close to the cylinder to minimize the effect of acceleration of water. The air vessel should be connected very close to the cylinder. In this length of the suction and delivery pipes, the acceleration of water is going to be takes place. So losses are taking place into only this length of the pipe in the delivery side and to the suction side. So the advantage of air vessel is to obtain a continuous supply of liquid at a uniform rate. So from delivery side we are getting benefit that we will be getting the continuous discharge. Second advantage, to save a considerable amount of work in overcoming the frictional resistance in the suction and delivery pipes. That means here when reciprocating pump is working without air vessel, the fluid has to accelerate and retard. So to provide more acceleration, pump has to work more. So when air vessels are used, then continuous flow rate with uniform velocity can be maintained. So extra acceleration is not required. So work done in case of air vessel is going to be decreases. So here it is mentioned to save considerable amount of work in overcoming the frictional resistance. Here one thing is also to be noted that when there is a acceleration and retardation, the frictional resistance is more. So when air vessel is connected, then constant liquid with constant rate can be supplied. So frictional resistance can be minimum with air vessel. Now to run the pump at a high speed without separation, from this indicator diagram it is clear that when speed of pump is more, this pressure is now less than the shown over here. So when speed of pump is more, this pressure drop takes place without air vessel. But when air vessel is connected, this pressure at suction side should not drop below the vapor pressure of liquid. That's why it is mentioned that it is possible to run the pump at high speed without separation. So these are all advantage of the air vessel. Let's see how can we find out the